Good afternoon.
Hello.
Okay.
I'm so sorry. I have a package at the door. I'll be right back.
Okay. All right, folks, we'll get started. We were working on
You want me to have mine on?
spring 2011.
I'm back.
Okay. All right, spring 2011. Let's see. I think we were on question. Here we go.
Number 4.
Number 4. That's right. Okay. So question 4 is a matching type situation, and the ones you want to match are down the bottom here. Now
Can
you
you
have
share
to.
the screen? I'm
Go on.
sorry.
Oh,
I didn't
I'm not
see
showing my screen, am I? All right. Here we go. Now I am. Okay. So it's a matching type situation. You have to be aware of symmetry here as well. So what I would do is, I think underneath each of these, it's probably not a bad idea to put down how many peaks you expect to see for each. And you can see that for the first one here, the one on the far left, you expect to see 3 peaks because of the symmetry straight through the NH2. So I'd write down 3, and I would also maybe even go so far as to put down what I expect as far as Q's, D's, T's, and S's go, and I would say Q, T, D is what I'd be expecting there. On the other one, the one next to it, I would go, that's 5 peaks, and I would again do Q, T, 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 D for that one. For the one next to it, Q, T, 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 S, and 5 peaks, and the other one 3 peaks, Q, T, D. So if you look at the two with 3 peaks in them, one has the D at 40 and one has the D at 60. So you can base that on the chemical shift there. The one around 40 will be the nitrogen one, the one around 60 will be the OH. And the other two, one is a D and one is an S. So the one with the D is the one that has the hydrogen on the C double bond O, and the one here doesn't have the hydrogen on C double bond O. So that's how you'd pick them out. And then I'm expecting you to label those as well. I mean, label the actual peaks with the numbers that are provided to you on the actual examples. Does anybody have any questions about number 4? I wasn't going to spend a whole lot of time on this because normally people don't have real problems with this one.
Dr. Musgrave,
Yeah.
for the symmetry ones that you have different numbers for it, can we just put one number, like if I changed?
Well, no, I would just go 1. So see, you could, I suppose, but I would prefer if you did, for example, for this one here, the one on the far right, on the D, I'd write 3. On the T, I'd write 2, 4, and on the Q, 1, 5.
Okay.
All right. Any other questions about number 4? Any other questions about number 4? Okay. Number 5. When I was going through this, I suggested that you sort of do it backwards, start at the bottom, work your way up. So when you've got, I'll just do the four things here. It says higher pKa, so you know that that's going to be less acidic. Then I'd look at them, and if you're looking at just straight acidity, I might be inclined to look at the anions. And further, maybe even draw those out. And then figure out if they're activating or deactivating. So that one's deactivating and the other one's activating. So then I would look at what we're looking at here. So less acidic must mean the anion is being destabilized. And that's because the anion is being hit with an activating group. And that makes it compound B. So the A here, I'll just write act and deact. Okay.
When I look at that at the top group, I'm seeing that as a withdrawing group ultimately once we get to the anion stage, right? Because the carbon is semi-positive.
Which is you talking about on both of these?
Well, yes. So you take off the hydrogen, so
Yeah.
oxygen becomes negative, which means the carbon before that becomes slightly positive, right?
Well, no, because this is where the negative charge is located. You're not interested in that group. You're only interested in whatever else is on the ring.
Okay. So it's just the negative side. We don't look at how each of the atoms are. So we're not looking at. Okay. That's where I get messed up. Thank you.
Okay. Any other questions? So which compound has a lower pKb? Well, here you're just looking at straight basicity here. Okay, so we're looking for the one that is more basic because it says lower pKb. And it will be more basic because electron density is being pushed into the ring. So we can see that the NO2 group here will be pulling electron density out of the ring. Whereas the ethyl group will be pushing electron density into the ring. So that's deactivating. And this one's activating. And it'll be activating because, well, if it's activating, then it's going to add electron density to the ring because it's an activating group. And that'll be compound B. And we got any questions? Hey, we got any questions about about number 5?
I do, but on the first one again, I don't know if you can pull that back up. Can you recall that?
No.
Yeah, dang, okay. Well, it ended up being a compound B was activating, it destabilized and made it less acidic.
Yeah.
So if the top section is negative because we've lost the hydrogen,
Mm.
and the bottom group is the activating, so it's pushing negatives in there.
Mm-hmm. Yes.
All right, never mind. I've answered my own question. Sorry. Thank you.
All right. Does anybody have any other questions about number 5? Okay. All right, number 6. Number 6 is the spectroscopy question. This one usually scares people who haven't done much spectroscopy, I guess. All right, so how do we go about it? Well, the first thing you do is you look at the molecular formula. And then you figure out the number of double bond equivalents. Okay, so 5 double bond equivalents on that one. Does anybody have any questions about how I'm getting that? The next thing I would do is I think the first thing I do after I do get double bond equivalents, I would look at the infrared and see if there's anything there that sort of reaches out and grabs me, or the absence of something that reaches out and grabs me. And just speaking for myself, I can see that there's no OH. I can also see that there's both the CHs from the alkene and alkane type groups. So I know that they're both present. And I also see a C double bond O. So that's all pretty good information for me. That's about all I'm getting out of the infrared though. And that helps me because now I know that there's no OHs in there, but I didn't really see any up here either. So it didn't really help me that much, I guess, but at least I know there's a C double bond O. That's something.
Dr. Musgrave, how do you know there's alkene and alkyl groups?
Because there's peaks on both sides of 3000, Courtney.
Okay, so even that little, like, really tiny one.
Oh, it's not that tiny. This one here.
Yeah.
Yeah. Well, yeah.
Yeah.
Yeah. I mean, if you look at the correlation chart, here's your CH stretch for alkane, and here's your this one here for alkene. You can see that it's sharp but variable. So variable means that it could be really any length. Okay. Okay, the next thing I would do is I would start off with C11H14O2 and then subtract out everything I see, which is C6H5, CH2, 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 and CH3. See what I've got left over. 6, 7, 8, 9, 10. So there's 1 C left over. 2 oxygens. This takes up 4 double bond equivalents. We agreed this was 5. And that means 1 double bond is left. So just a C double bond O and an O. Those are what's left. So now I put the pieces together here, and I usually like to look for something around 4 ppm because that would indicate that I've got something connected to oxygen. So it's the CH2 here, and that CH2 happens to be connected to a CH3, and I know that because it's got 4 peaks there. So I know that that's a big portion of it. So then the rest of it is fairly easy to put together. These two CH2s have to be next to each other because they're each 3 peaks, which indicates we got a CH2 next to a CH2. So there's really only one thing I can put down here. And that would be this structure. Now, if we look at the carbon-13, we can figure out if that actually fits. We got a Q and 3 T's, and we got a T here at around 60 connected to an oxygen, but that would be definitely that carbon that I'm pointing to right here. That would be the T that's around 60. And these other 2 T's are a little bit hard to distinguish. I don't know if I'd like to even guess which is which out of those, so I'd probably take it either way. You've got the aromatic ring there, which is the DDDS type situation. And then the other S is the C double bond O. Does anybody have any questions?
How did you know that the C double bond O was in between the O and the 2 CH2s instead of being in between the aromatic and CH2?
Okay, because that would mean, if that were the case, Courtney, then the O would also be connected to this CH2, right?
Yes.
And if that were the case, that peak would be around 4 ppm as well. It'd be
Okay.
next to this one. But because it isn't, I know that it must be connected to a C double bond O.
Okay.
The other clue is with the aromatic ring region, there's only one set of, or one grouping of peaks there. So that suggests it's connected to an alkyl group and not, say, a C double bond O or an O, where it would be split apart. All right, does anybody have any other questions about number 6?
Yeah, I do.
Mm-hmm.
I have the same structure, only mine starts off with a benzene, then it's a CH2, then it's the C double bond O to the other O, and then what is it? CH2, CH2, CH3. So it's arranged a little bit differently. How can I know, like, how can I correct it? Would I do the breaks and then it would tell me that I did it wrong, probably?
No,
Or-
because if you had what you said you had,
Mhm.
then the CH2 between the C double bond O and the ring would come up as a single peak.
Okay, so that's
You have to look at the multiplicities, Jasmine.
okay. That's where I'm having the most trouble, I think, with this.
All right, because if you were looking at these two, I'll go ahead and number them.
Okay.
So this is labeling just for the hydrogens. The 5H would be EFG.
Mhm.
The 2H that I'm pointing to with the cursor right now would be B.
Okay.
The 3H would be A.
Mhm.
And these two would be C and D, but I don't know which is which. But
Okay.
if you look at C, it's CH2 and it's next to 2 hydrogens because there's 3 peaks. So 3 peaks means 2 adjacent hydrogens. And this one's in the same situation. 3 peaks, 2 adjacent hydrogens. That's how I knew they were next to each other, Jasmine. Now in the correlation chart, I didn't mean to do that.
No, you're fine.
If you look in the correlation chart, oh, that's, I think I hit headers and footers for something. All right. I have got multiplicity guidance here, so it tells you how many, it gives you some idea about what you're talking about with the number of peaks.
Okay. Thank you. I probably just need to practice more with that.
Mhm.
That's probably why I keep getting the wrong structures then too. Thank you.
So one thing I would suggest for practice then, since you're bringing it up,
Mhm.
would be to use this NMR tool that I came up with.
Okay.
Have I showed you this before?
So yeah, I just never got around to it, but I think I'm going to do that today.
I think it might be a good idea,
Mhm.
because then, you know, you got to wait for it to pop up. But once it pops up, then you can figure out the double bond equivalents. This would be C9H10, 5, I think. No.
Oh,
Yep.
okay, I see it now. I was confused where you're reading the numbers, but it's right there at the
Okay.
top.
Yeah, that's right. Then you pick the pieces, and there's a C6H5, and then you got 2 CH2s. That's all you can see there. And then what's left, a C, an O, a double bond, and a Cl. So there'll be a C double bond O and a Cl. And then you check the pieces, and then you drag them down. And this is where it sort of comes into play, Jasmine, because it'll give you the wrong answer. They'll tell you your answer's wrong if you don't arrange the CH2s properly. So those have to go in alphabetical order. And then you submit it. If it's right, it'll tell you it's right. If it's wrong, it'll tell you it's wrong and give you a chance to redo it. But the thing is that once you get it right, you can click there for a video solution, and that will help you with the multiplicities as well, because I get to explain the whole thing through there.
Oh, cool. That's awesome. Yeah, I think I'm going to mess around with this all day today.
Yeah, it might not be a bad idea. A lot of people don't even bother with it, but they should.
Okay. Thank you for showing me this.
Okay. Right, so that's in the NMR exercises folder. The link is anyway, and it's on my website. Proton NMR exercises and answers. That's where you'll find the link to it. And that's in the, you can see it's there in the table of contents. All right. Any other questions about this one? About number 6? Okay, the other complaint I usually hear is from people who never did infrared. And, you know, and sometimes I get some pushback saying, well, look, how are we expected to do this? We haven't gone over it in class. Well, I feel like I've got enough resources for it in these 2 videos here, Introduction to IR Spectroscopy and Infrared Spectroscopy, Peak Shapes and Locations. I really feel like both of those and the example here give you enough to go on in order to be able to figure that out. Some people might agree, some people won't, but that's what I think. All right, does anybody have any questions? Okay. Now the last one is a synthesis problem that involves diazotization.
Can I ask you a question?
Yeah, Julie.
On the diazotization ones, in the last test that we had with this type of thing, there were choices on the first question to look at to tell the last, to be able to choose from on the last one. But on this one, I noticed that there aren't.
Mm-mm.
Does that mean that we have to memorize all these small ones where it's like F, like what, how do you get the F?
Yeah, I can't think of any other way of doing it, Julie.
Okay. Okay.
But, they're all a source of something negative. That might help. Because if it's CUBR, CUCN, CUI.
Yeah, that one I know, but it's the F the F and some of the other ones.
I know.
So I guess it's just a memorization thing then.
Yeah. Well, I wish there was another way around it, but I can't think of another way.
Okay. Are they all going to be ones that you've already gone over?
No, well, they're all going to be ones off that list that's on the PowerPoint.
Okay.
It's in the videos as well.
Okay.
Okay. So HNO3, H2SO4 for the nitration. Then hydrogen, palladium. And then I like to just do this last thing as a two-step process. NaNO2, HCl, 0 degrees, and 2 would be HBF4. And that's what you were talking about, Julie, HBF4 and heat. And that will give you the product which has the F on it.
Does it matter if you write HNO2 instead of NaNO2?
As long as you put, it's really, it'd be either NaNO2 and HCl or HNO2. Either one of those is fine. Okay, any other questions about number 7?
For that one you did in 2 steps, you can do it in like 2 separate arrows, right?
Yeah, that's right. If you're going to put the intermediate with the N2 plus on it,
Yeah.
Courtney. But I think it's easier just do it the way I've done it.
Okay.
Okay, any other questions?
Not on number 7, but I have a few quick questions on question 1 on all of the reactions.
Okay, we'll get to that. Get back to that in a second.
Okay.
Is Emanuela here? I haven't checked. Let me check the. No, I can't really check. Emanuela, you here? Suppose I could check it right here. Amelia, sorry, Amelia. I meant Amelia. Yeah, Amelia, I see you here. Amelia, can I talk to you after class, please? Amelia?
Yeah, you can talk to me.
Thank you. Appreciate it. All right. Anybody else have any questions about number 7? Okay. Then I'll take questions about the rest of the test. So so Donna, you said you had something about number 1?
Yeah, just little things. So like in question 1, I came across for the fetal cross-acylation primary. If the primary carbocation can shift to both a 2nd degree and a 3rd degree, do we show just the most stable 3rd degree or 2nd and 3rd or all 3 as products?
Well, I would say definitely the primary and either the tertiary or the secondary would be fine.
Okay.
But you could, if you showed all 3, it would really warm my heart.
Okay. Well, we like to do that. So, All right. Then for a Friedel-Crofts that is a 3rd degree with an activated group, we only need to show the mechanics for the 2 products, right? Not the whole resonance and the meta versus
no, that's right.
non-favorable.
That's right.
Okay.
Yeah, It would just be, well, let's see. Let me show you an example of that. So what Donna's talking about, just so everybody's clear, sometimes people get twisted up about this, but if you look at the mechanisms, you can see here that what the student has done is put the mechanisms on here. That by the way is my annotation, I think. But you'll notice that there's no, it doesn't show all the resonance. I'm not expecting that. I just want you to show the mechanism. The other thing is that if there's two products like a chloro and an ortho, you don't have to show both. If you can just show one of these, that would be fine. Either one.
Oh. Good, very good to know.
Okay.
And then one other one for the, let's see, Okay, for the electrophilic substitution during diazotation at room temperature, is the side product captured properly as a continued reaction with the addition sign, or is it a second product? Does that make sense? Because you have the salt is created, and then the salt, half the salt reacts.
No, because it does just produce one product.
And the product is the combination of the two.
Yes, that's correct.
Okay. Okay.
Now,
And then-
let me see. I'll see if I can find one here. There we go.
Okay.
Yeah,
Yeah,
so
it's in there.
that would be the only product.
Okay. Okay. And then as a matter of strategy, because obviously we get, bonus points for doing the mechanisms. As a matter of strategy, does it make sense to put the products down, finish the tests, and if you have time, go back and put the mechanisms in?
That's definitely what I recommend, because the extra credit isn't worth that much, and you might not get the point anyway.
Right.
If you make a mistake. So you're best off getting as much of the other stuff done as you possibly can, and then coming back and doing the other stuff for partial credit later, extra credit later.
Okay. And I think this is a silly question, but I'm going to ask it anyway. Can we use pencil, or do you require pen on the test?
Well, if it's pencil, then I want to be able to see it. That's my main thing. I just need to be able to see it.
Okay.
Right? And if it's so light that I can't see it, then I can't grade it.
Makes sense. Okay.
Can I add to that too? I was using pencil in my last work, and when I was taking PDF, like a picture that converts it to PDF, it does this weird thing with the color that pencil disappeared. So I recommend, if you're taking pictures, you can do pencil, but if you're doing PDF scanning, do a pen, because otherwise it kind of discolorates and disappears. So
good call out. Thank you.
All right. And the other thing is if you're one of these people who has trouble with the sending of pictures, try an app called Cam Scanner, one word, CAMCASCANNER, that allows you to take pictures you've got on your phone and convert them directly into a PDF file, so you can send the PDF file. And the PDF is going to be a lot smaller than the pictures, so it should take a lot less time to upload. Because remember, I do give you some extra time to upload the pictures, but if you haven't uploaded it by 2 o'clock, then you're done. That's it. I'm not gonna accept it after that. So you have to make sure that you've uploaded it by 2 o'clock. All right. Other questions about the test?
Dr. Musgrave, can you
Yeah.
give an example of like the Friedel-Crafts rearrangements where it goes from like primary to secondary and tertiary?
Donna, do you remember which one you asked me about?
Yeah. Give me 1 second. I'll find it for us. Hold on.
and we still see your screen, just FYI.
Sorry, yeah, I just realized that. Here I was
Well, it's-
thinking, oh yeah, I'll just check my email while I'm at it.
The one I asked you about was, let's
Yeah, I lost it.
see,
Yeah.
or page 4 on 2009. It was in question
I
one.
actually had it had it there at the
Yeah,
beginning. Already had that one. All right, hang on. Let me get back to where I was. Sorry.
yeah, because I did get your answer, but I was, and so that I have a good variation of it, but I couldn't figure out how that, the one that was on the test, I couldn't figure out how he came up with that one though. So,
Oh, well, no, I mean that one. Hang on, it's keys. Okay.
so it should be on page 4, about halfway. The second one.
Yeah, very
Yeah,
good.
there you go.
All right. No, Donna, he came up with this one, or she, or whoever, just by doing a hydride shift, just taking a hydrogen, moving it over.
Yeah, that one I had no problem with, but his version, if you scroll down just a smidge. So
Yeah.
it's the second one where it looks like a bird. How
Mhm.
does he come up with that one? Because, or they, how did they come up with that one? Because I could never
But-
make that configuration doing a single methyl shift.
You can't. I mean, because that's no shift at all. That's from no shift at all. This one down the bottom here
Yeah.
is from no shift.
Oh,
Now, to answer, Victoria, was it you who asked me about somebody did? Somebody just asked me about it. Who was asking me about the other possible secondary
Who
one?
was Courtney?
Might have been Courtney. Sorry, Courtney. Yeah, that's right. All right. So this might help. Donna, I think I might have been a little bit confused by your question, to be honest, Donna.
that's okay.
I mean, initially when you asked me on email.
Yeah.
Anyway, because you did pretty much what the other possible way of doing it. And Courtney, this is the answer to your question. Now this is primary presently, but if I was to do this and shift it, I'd end up with this. Actually, I'll make that an H there. All right, so that product then would look like this. So this is primary, this one would be secondary, which would also be possible as well. But if you showed either the secondary or the tertiary, I could live with it.
Okay. So, and the hydride shift created the tertiary.
That's right.
Yeah. Okay. So we don't have to do all three, but it would warm your heart if we did.
Yes.
Okay. But it's the primary that we have to show. The primary
Yes.
was the one.
Yes, the primary and either one of the more stabilized ones.
Okay.
Because the secondary one's possible. I mean, based on what I was talking about in the class, sure, it's possible.
Okay.
Courtney, is that okay? Did I answer your question?
So we could either show the secondary or the tertiary.
Yeah, but you wanted to know the secondary one product, right? Or you wanted an example of it?
Yeah, I understood how the hydrogen would shift, but I didn't see that. But you can shift any bond connected to the C that's connected to C8 or C plus, right?
Mm-hmm. That's right.
Okay, that makes sense.
Okay. Any other questions? All right. How about, okay, Donna, you had another question for question 1?
No, you've answered them all. Thank you.
Oh, oh, that's good. That's
Woo-hoo.
wonderful. All right.
I have a question.
Yes, Julie.
Well, two. One is something you just said is you can shift any bond. So any of the bonds can move over and connect to the positive charge. That's what you're
I've
saying?
provided, there's a caveat there, Julie, provided it's producing a more stable cation than what you already have.
Okay.
Because the initial one's primary. If you're producing a secondary or a tertiary, that's fine. But if you're on a secondary and you're producing another secondary, that doesn't help.
But this picture here that you have on the scanned document, okay, there's two answers. They're drawn out.
Yes.
And the first one is not the primary, is it?
No.
That's the secondary,
Tertiary.
tertiary. The first one, the one to the right, the second one is what? Primary?
Yes.
Okay. And my other question was, in some places you have H2PD and in other places you have H2PDC.
Mm.
What is the difference?
There really isn't one.
They're the same thing?
Mm-hmm.
Okay, thank you.
Any other questions?
Can you, for this structure, I'm drawing it. There is the primary that was initially formed. And then we did a hydride shift that gave us the secondary. How are you making?
Tertiary.
This is secondary.
Where? Which where are you talking about, Miriam?
Your second carbocation, the positive charge that attached to a carbon that attached to two other carbon, a CH2 and a CH2, CH3 on the bottom.
Hmm.
So that's secondary, and you wrote right there.
No, that's primary.
The primary is the top one that you just drew on your whiteboard.
No, that's
your-
actually the
On your,
secondary.
sorry.
Miriam, look at my cursor here. This one's tertiary. Okay. Tertiary. This one is primary. Look where the positive charge is.
Yes, but look on your whiteboard. She's referring to the ones on your whiteboard. It's the methyl shift, the bottom one, the one you're pointing at. That's the
Yeah,
secondary.
That's
She's talking-
secondary. Yeah.
So,
Yeah.
okay, so that's what I was referring to. So that is
okay.
the top one that you drew is primary. Can you show me how do you get the tertiary one?
Right here. Right here, Miriam. It's shown right here on this page where my cursor is. It's a hydride shift. So moving that H over onto the CH2 plus creates the tertiary C plus.
Okay.
You sound skeptical.
Yeah. Well, I see it right now, but I did a hydride shift and I got a secondary. So how do you get a secondary then?
Only by doing an ethyl shift.
You did the ethyl shift, not methyl.
That's right.
Oh, okay. I think now I get it.
Yeah, I can't move this bond here. I have to move a bond adjacent to C plus.
Okay. You did a hydride shift. So the hydride shift gives you tertiary. That's right. Okay.
Mm-hmm.
Okay. I understand it now. Thank you.
Okay. And other questions?
Okay, so if you're talking about the pK of a conjugate acid, or you're looking at the stability of a conjugate acid, if it's a regular acid, if you're looking at the anion, you're looking at more stability means
Well, hang
more
on.
acidic.
Why don't we pick up another?
Yeah, pick one.
I'll pick this one.
Sure.
Well, no, why not? Let me get the. Hang on. Hang on.
Well, I know there's an example in 2009, the second one, but it's up to you. You can do whatever one you want.
I want to pick up the original one from the file rather than the key. Actually, I'll do 2019.
Okay.
Okay, so you're talking about this one here, right?
Well, yeah, that kind, yes.
Okay. So what's your question?
Well, I get turned around on the conjugate acid because I'm looking at that going, okay, more stable means more acidic, but it's the opposite there. And so that's where can you just do one more for me? You've given so many examples. I know this is me. I just get turned around on this and I don't know why.
Donna, to help you, the easy way to remember it is it's always just the opposite. So if it says it's higher, it means it's less acidic, and it's for the base too. So if it's more PKB, it's just the opposite. It's always the opposite of what it's asking you, and then you just start from the bottom and go up basically.
Well, no. I'm good on the pKa and acidic. That part I'm good on. It's more about once you've added in the H and we're looking at the conjugate acid, knowing whether an activating group or, you know, if you're stabilizing it, whether it means it's more acidic or less acidic. That's where I'm getting. Does that not make sense?
Yeah. Okay. We'll work on that. Well, deactivating groups always subtract electrons as well. I think that's helpful too, Donna.
Yeah, see, the question I looked at on 2009 was talking about the stabilizing. And so activating and subtracting, or activating and adding or not.
Do you think maybe there might have been a reason I might have
changed
changed the question?
Well, you know, now that you mention it.
To be more cruel and to be more mean.
Oh, is that right?
Actually, I was being less cruel by doing that. But you can see that, well, if we're talking about stabilizing, then the deactivating group destabilizes the conjugate acid.
Okay.
It'll make it more acidic.
The deactivating group.
Yes.
Destabilizes and makes it more acidic.
Yes.
Okay.
The conjugate acid, Donna.
Okay.
Whereas the activating group stabilizes the conjugate acid, makes it less acidic.
All right.
I don't know if that's helpful or not, but anyway.
Okay.
So this one, whatever's, you know, the one that's less acidic, yeah, that's going to be the one that it has the more stable conjugate acid. But the activating groups always add.
And I am right that that's the opposite of if this were an anion.
Yeah.
Okay, so more stability means more acidic on an anion, but on a cation, we're talking the opposite when we're looking at the cation. Okay,
that's right. Yes,
that's why. Right? Hey, it's more stable. I got to make it. So that's where I keep tripping up, and I don't know why I can't just learn it. So there you go.
because what works for positive charges works oppositely for negative charges.
I know.
All right. Okay.
Thank you.
Okay. All right. Any other questions? Okay. Other questions about the test? All right. So let's go through exactly what you'll be doing on Thursday. What will happen is you'll go in. What will happen is you'll go in where is it? Where is it? Here we go. Test one. Okay, so in the test one folder, there's going to be a quiz called test one access. You could probably even see it already, right? The quiz. Yes.
Yes.
Yeah, but you can't access it, obviously, right? Okay. So you can see that it says it starts here February 11th at 12:20. So that's when it will be available for you to look at. So you'll go into that quiz, and once you enter it, there'll be a link to the test one file in there. Then you download it and you print it out. Okay. Then you do the test, and then you take pictures of it, and then you put it into a single file, and then you upload it into the Dropbox that's below, and that's due at 2 p.m. If you're super quick about printing it out and super quick about uploading it, you can give yourself a little bit of extra time on the test too. But I've given you plenty of time to do both of those activities.
So meanwhile, we don't start the test though until we're logged into Zoom.
Well, I would expect, yes, you'll be logged into Zoom when you do this, when you start accessing it, yes.
Okay, perfect.
And I reserve the right to ask people to survey their room with their webcam and a hand mirror. All right, so I could ask any of you to do that. So, you know, don't be putting notes and crap around the place out of sight of the webcam. It's hard for me to prevent it, but I don't know what else to do. You know, I don't know. I hope people don't cheat, but if I catch anybody, boy, I tell you what, they're in for it. I'll make sure they get expelled, I tell you. Or at least I'll do everything I possibly can to get them expelled. Let's put it that way. Even if I can't do it, I'll certainly make life very difficult for whoever does it. I'll tell you that. You don't want to get on my bad side when it comes to cheating. Nope. All right. Any other questions about how test is going to be run?
Dr. Musgraves?
Yeah.
If we don't have a hand mirror, would it be okay to just have the computer, and if you asked us to just show the camera around?
Yeah, that's fine. If that's provided you can take the camera off. Sometimes it's part of the monitor.
I was going to ask the same
well-
thing because I don't know what a hand mirror is.
A hand mirror, it's just like, I don't know, a mirror you hold in your hand. If you're not female, you might be able to grab one from a female. I don't think it's too much to ask that people have a hand mirror. Is it too big a burden to have a hand mirror? Peter, do you know what I'm talking about or not? Peter?
He walked off screen.
Oh,
Probably getting a mirror.
he might be getting a mirror, I don't know.
There's a dollar store you can buy a mirror for $1 or $2 just in case. The big one, not like, you know,
Yeah,
small one. So it's also
that's a possibility.
I have a question.
Yeah. Mm-hmm.
So when we do the Dropbox, can they be put in as a picture, or does it have to be converted to a PDF?
It has to be converted to a PDF or an MS Word file.
Okay.
But you know, you're doing yourself a disservice if you don't make it small. I mean, if you have a file size that's like 200 megabytes, you're making my life hell, and you're also making your own life hell. Keisha will tell you that. But Keisha's figured out how to get her files smaller. So I'm proud of Keisha. You on the call, Keisha? No, Keisha might not be here. But anyway, that's what you should do. If you use Cam Scanner, I know your files will be a decent size.
I'm not seeing Cam Scanner for Macs.
I've got no clue. Oh no, it wouldn't be. It's a phone app. It's not a. It's
Well, I'm on my iPad coming up.
Yeah, you have to. It's for your phone, Donna.
Okay, all right.
But I don't know. Maybe there isn't one for Apple. But you can use something different for Apple. I think you can use Notes or something. I don't know.
There's a cam scanner. I just looked it up on my phone. You can get it with Apple.
Okay.
Oh, it's on Apple. That's cool. Thank you. I haven't checked yet.
Yeah.
I have a question.
Yeah.
With the test, do we need to sign on it and with the spoon as well?
Say it again, please, Billy. I'm sorry.
With the test, do you want us to sign on it too as well? Our
Yes,
name?
please. Yes, I do. Yeah, I do want you to sign each page. Yeah.
I have a question about the signing.
Yeah.
When you say sign across the whole page, do you mean like over the stuff you wrote?
Yep.
Doesn't it block what, like on
No.
the labs and stuff, doesn't it block what you're trying to read?
Not for me. I must be some sort of genius because I seem to be able to manage to read through it, Julie.
Okay. I always feel like I'm about to block everything I drew. That's why I do weird stuff with that.
Yeah, that's all right.
I've been signing it across with a highlighter instead of an actual pen.
Yeah, that
Does
works
that work
too.
for you?
Yeah, it works for
Okay.
me. Yeah. So you could do
Makes
that
it
too,
easy.
Julie, if you wanted.
If I had a highlighter, which I don't, I can do it in pencil. It's just that my work is so sloppy by the time I'm done anyway. I always feel like, especially with the labs, I feel like I'm drawing right over what I did and you'll never see it.
No, I don't feel that way about it.
Okay.
Dr. Musgrave,
Yes, Victoria.
have we finished with the review and the housekeeping stuff? Anything else after this one?
I don't think so.
Okay. Can we go?
Oh, anybody can go at any time, Victoria.
Okay,
I
I don't want to miss any information, but
Oh,
I'm
well,
not-
I don't think there's anything else I need to talk about, but I don't want to cut anybody short on their questions either. So, but one thing I don't know, Victoria, is whoever else has got any questions.
Okay.
So on the test, we're not going to have any questions like the ones that were on the lab that were really hard. Like it would have carbon and a percentage, and then you would do that. You don't think there's gonna? Okay, that's cool. I just want to know because
No. If you look at the old tests, it's going to be formatted pretty similarly.
Okay. Do you mind doing one more problem like that just so I can follow your thought process and work along with you to see if I'm doing it right? And just because. That's
Yeah.
all. I get it, but I just want to see more. Thank you.
So Dr. Musgrave, if we took you last semester, the tests are going to be like the same, how we like to get into them. Right?
Could you repeat that, please, Courtney? I'm sorry, I didn't hear the question.
Like how we take the test is the same as an Orgo 1. Right?
Yeah. Yeah. Pretty much.
Yeah.
All right. Let's see. Maybe I'll do spring 2018. It's just completely random, Jasmine. Okay. So C13, H19, and O. Do the double bond equivalence first. And C13H28. So 28 minus 18 divided by 2 is 5. 5 double bond equivalents. That's what I do first. So first of all, that's 5 dBE. I figure out what I can see, what I can't see, and I see a C6H5. I see a CH3, I see a CH2, and I see three CH3s. 6, 7, 8, 9, 10. I'm missing 3 carbons. 6, 7, 8, 9, 10, 11, no, 2 carbons. So missing 2 carbons, oxygen, double bond equivalent, and another O. Okay, and then I have to try and put it together.
Wait, there's only one O.
Only one O? I'm sorry, you're right. Thank you. Okay. You're right, there's only one O, thank you. But there's also an N, right? That's what I meant to put. And the N has 3 bonds on it. That's important to note too. So when you're looking at the infrared, you can see that there's no NH and there's no NH2, because those would actually, if you look at the correlation chart, NH and NH2 would look like this, and they would appear in the 3500 region. And they're not there, so it must be an N that's got 3 carbons connected to it. And with the 9H there, 3 CH3s in the C, I think it's pretty automatic that we could go straight to 3 CH3s connected to the C. And then we've got a CH3 and a CH2. So I think from there, I'm looking at the where they're located as well. And with the CH3 being at about 3 ppm, I think it's connected to a nitrogen. And CH2 is probably connected to the nitrogen as well. And then we've got the C double bond O and the aromatic ring to take care of. I'll probably put C double bond O in there, put the aromatic ring up here. That's probably how I would do it. But with the CH2 here, it's kind of, it could be either way. We could, I think these two groups are somewhat interchangeable, the ones I'm circling. I think those could be switched around, and I don't know if it's possible to say. Let's have a look. Maybe we can look at the carbon NMR and we can see. Well, maybe we can say, because if you look at the single peak here that's at 45, that would be this C. So I would say that would more likely be connected to the N based on the carbon NMR. So I would switch these around. And the final structure then would have the N connected to the C down here. That's very subtle, but yeah, I think we can tell that based on the, yeah, based on where they are on the carbon NMR. So the final structure then would be that. Okay, any questions?
Can you explain one more time, how did you decide to switch those two groups?
Look at the S group here in the in the carbon-13, Miriam.
Okay.
That has to be this C here. It's connected to the other 3 CH3s. There's 2 S's or 3 S's in the compound. One's an aromatic S, one's a C double bond O, which is the one over here. So the other S has to be this one. And since it's at around 45, it must be connected to nitrogen. You can use the correlation chart down here to determine that. See C to N, where are we? C to N around 40, see?
Okay, so the CN bond, that's around 40. So that S,
Yeah, it's about 50, close to 50.
okay, so why am I confused? So that S is the one that is bonded to the nitrogen, the
Yes.
CH2 benzene that is bonded to nitrogen. But why should you switch it? Why does it matter to switch it? You just assign that to that C.
Well, if you look at, yes, but if you look at this, the C connected to the C double bond O is not going to be down at close to 50. It would be more down here, like at 30 or something.
Okay.
Let's have a look. There we go. C connected to C double bond O, closer to 30.
Okay.
See that?
Mm-hmm.
So the CN is higher than the C double bond O.
That's why so that's why the 40 is the CN should be more downfield than the C that is connected to C double bond O.
Yes, that's right. That's right. Any other questions? I think the one reason people might not get this one correct is that they don't realize that nitrogen has 3 bonds. You know, if you think nitrogen only has 2 bonds, then you're never going to get this one right. All right, any other questions?
Are we doing naming on the test?
No.
Okay, thank you.
But that's a good reminder for me to make sure that you do get your aromatic naming quiz done. That is part of a test. You mean the grade is part of the test, so you do need to do it. All right, any other questions? Any other questions? All right, well, we'll leave it there for today. Good luck, and I'll see you Thursday.
Bye, everybody.
Thank you. Amelia, don't forget, I want to talk to you, please.
Okay.
I left for a bit, so I might have missed the question. Can I ask that one?
Possibly. What is it, Peter?
It was on the same type of problem on the 09. I just had a question about if you really wanted to know where the 2 CH2s lined up, could you figure it out from the data?
No, I don't think so.
No?
No.
That was it.
Okay. All right, it's just you and me, Amelia.
Hello.
So I have a bit of a problem, and I just wanted to see if I could impose on you here a little bit. With regard to the test, you do need the extra time, so I thought, well, you should start it early. But the problem is I'm in the lab before that, and I can't be on 2 Zoom sessions at once.
Okay.
That's right. So what I'm going to ask you to do is start with everybody else, but you'll get longer.
Okay.
All right. So I just want to make sure you didn't have an SPC class after my class.
No, not on Thursdays.
Okay. Well, what about Tuesdays?
Tuesdays are my busy, crazy days.
Can you answer my question though, please? Do you have an SPC class
Oh yeah,
at 2 o'clock on Tuesday?
not on 2 o'clock.
What time?
No.
What time?
I
is
have
it?
it later in the day, so 6.
Okay,
Will be
all
good.
right. So you can still do that 10 too. All right, so that's how it's going to be. You're going to start with everybody else, and that makes it better anyway, because then it doesn't look weird with you already having started and people coming in and they all know you've got accommodations. And I don't
Yeah.
like. I'm not a real fan of that.
Okay.
As it is, you'll just stay on the call.
Okay.
Okay, when everybody else is gone. All right.
Okay.
Okay. All right. That's it. Thank you.
All right. Bye bye.
Bye.